Hi, I'm Tyler Vanderplug from JDSU, and today I'm going to show you two of the JDSU inspection and test kits that are used for AT&T Mobility's cell tower turnup. Let's take a look. Let's start by taking a look at the kit that's used on the bottom of the cell towers, also known as the AT&T 14 kit. All the contents in the kit are kept in this portable shoulder carrying case here. The first thing is a probe microscope. This is a digital microscope that plugs directly into your PC or laptop so that you can inspect and certify the end faces of your connectors. Next in the kit is the optical light source. There's a couple of batteries and components with that. In the next compartment, starting off with an LC cleaning tool, this will clean both the bulkheads and the patch cord side of the connectors. In here is a visual fault locator. It has a portable canvas carrying case. Also in here, a USB optical power meter, so it plugs also into your PC or laptop and allows you to get your power measurement readings. Also in here are various tips and adapters. I'll go through the details of those in a second. And then there's a nice little portable carrying case that comes with those. Finally, some additional accessories and parts in the back of the carrying case here. The software installation disc, a couple of patch cords here. These are LC patch cords, and the user manuals and certification materials. Alright, now I'm going to show you the various tips and adapters that are included. They're all contained in this small bag here, and as I remove them, I'll put them in this tip storage case here, which is just a safe and portable place to put them when they're not being used. Alright, starting off with the various tips that are used for the probe microscope. First is the FBPT SC. This tip here is used for inspecting SC connectors that are located behind the bulkhead. Next is the FBPT U12M. This is actually used for inspecting LC patch cords, or actually it'll work for any connector that has a 1.25 millimeter ferrule, but in this application it's primarily LC patch cords. Next is the FBPT LC. This is actually used for inspecting the connector behind the bulkhead for an LC. Just put this on to the end of your probe and you can inspect that connector. And then finally is the FBPT U12A6. Now there may be times when you're inspecting an LC connector where it's a really dense application, or maybe the LC bulkhead is a little bit hard to reach. And so this tip here has a 60-degree angle on that. So you put this on the end of your probe microscope and it allows you to get into those tight spaces a little bit easier than with the regular LC bulkhead tip. Next are various adapters and other accessories used for other devices included in the kit. Starting off here with the FFL 050-U12. This here is an adapter that goes on to the end of your visual fault locator. If you just remove the tip, the cover from the end of the VFL, it already has an interface here that works for any 2.5 millimeter adapter, and this here will allow you to convert it so that you can just put this on the end, and now you can use the visual fault locator with a 1.25 millimeter ferrule. And then finally is the FITP UPP12. On the end of your USB power meter, there's already an adapter on here. This interface here is by default used for 2.5 millimeter ferruled connectors. If I just give it a few thread turns here, I can remove that and then attach the 1.25 in its place. Alright, now let's take a look at the kit that's used at the top of the cell tower, also known as the AT&T 15 kit. Here in the top compartment of the carrying case, first we have our handheld display here. Next is a probe microscope. Now this probe microscope, instead of plugging into a laptop, actually will plug directly into the display here. And then Here's a nice accessory that comes with it. It's a hands-free carrying case so that you can put your display, your probe, and all your different accessories all into this device without having to hold on to anything. You can just put it right around your neck and it keeps your hands free. In the second compartment is an IBC cleaning tool for LC connectors. This will again clean both the bulkhead side and the patch cord side. Here is a power supply. Here is a bag again that contains various tips and adapters and items that are used with the display and the probe. Here is a portable battery charger that already comes preloaded with batteries. So this gives you enough batteries here to operate the handheld device. And this is a rapid charger that charges in around 15 minutes. And then here is the power supply for that. In the back section here is the user manual and a little envelope that contains what's called an image grading overlay. And this is used as part of the evaluation process of your connectors. I'll show you how to use that later on. Now here are the different tips, adapters, and accessories that are included in the AT&T 15 kit. I'll start off by showing you some of the tips that are installed on the end of the probe microscope. Starting off again with the FBPT SC. Again, this is used for inspecting SC connectors located behind the bulkhead. Next is the FBPT LC. This is used for inspecting LC connectors behind the bulkhead. And then finally, again, the FBPT U12A6. This, as I mentioned before, is used for inspecting LC connectors that are in hard-to-reach areas. Now I'm going to show you how to use various adapters to inspect different patch cords. Starting off, I'll show the FMAE LC2X. This here is an adapter that actually attaches right on to the integrated patch cord microscope on the video display. The video display already comes with a default adapter attached to it, which is for 2.5 millimeter ferruled connectors. You can unthread this and then replace it with this one. And now you can actually plug in your LC connectors right into here, and as you slide it back and forth, it allows you to toggle between the two ferruled interfaces. And then finally, we also have an FMAE U12, which can be used in the same way, only just for simplex applications. After the adapters, we also have this little adapter here, which is used for our VFL. There's also a VFL that's integrated right onto the video display here. By default, it has a 2.5 millimeter interface, and I simply just attach that in here, give it a quarter turn, and now this will work for 1.25 millimeter adapters like an LC. And finally, included in here are a couple of different adapters that you can plug your LC patch cords in. First is an LC duplex adapter, and the second is an LC duplex loopback, which I'll show you how to use later on. Okay, now that we've gone through all the contents of the AT&T 15 kit, let's go ahead and get it set up for the use actually up on the cell tower. We'll start off by using this hands-free carrier here that comes with the kit. This will hold all the contents of the kit so that you can climb up the cell tower and do the work that you need to do. The first thing that you want to do is put the HD2 in there. There's two little clips that can be undone, and then just drop the display right in there. Now by default, the HD2 comes with this universal 2.5 millimeter adapter, but since at the top of that cell tower everything is an LC duplex connector, we want to use this FMAE LC2X, which allows us to inspect those LCs a lot faster. So just thread that on there and you're ready to go. Next, you're going to want to put the probe on. You can start by just putting the probe right down the center pocket in the back, and the connector here will thread right onto the side of the display. Give that a turn until it goes into place and thread the coupling nut over. Now your probe is attached. But before you use this probe, you're going to want to make sure that you put the right tip on. And since everything on the top of that cell tower is an LC, you want to use your FBPT LC tip. Remove that protective cap and put on your LC tip. Now you also have your cleaner. There's a storage place right here on either side for your cleaner. I usually like to put it on the side right next to the FMAE adapter. Okay, so now you have your HD2 display in your carrier. It includes your FMAE adapter for inspecting the LC patch cords. You have your probe microscope with the LC tip on there, and you have your LC cleaner, all the equipment that you need to go up the cell tower. Next, all you do, put this around your neck, keeps your hands free, and you're ready to go up the cell tower and do your work. Now we're ready to prepare all the fiber connections up at the top of the cell tower. All the fiber connections are located inside this ray cap enclosure here. Let's take a look inside. To do that, remove this protective seal and slide this out. That will reveal a series of 24 LC fiber connections located in here. Now what we're going to want to do is make sure that all of these end faces are clean, and then we're going to inspect all of them. Now the arm here of this bulkhead enclosure can actually swing out. There's a little screw that can be removed, and this swings out, giving you easier access to all the bulkhead ports here. Let's go ahead and get started. Okay. Now I'm ready to make sure that all my connections are clean up on the top of the cell tower. I'm going to start here with my AT&T 15 kit around my neck, and I'm going to use this loop back here. I'll show you how to do that in a second. But first, I want to make sure that the ends of this loop back are clean. So remove the dust caps and insert the loop back into the FMAE adapter and turn it on. Get that in focus and inspect it. Now if it's dirty, with this side here, first side is clean, second side is a little bit dirty. I just put that into my IBC cleaner, leave the cap on, give it a click, re-inspect that, and now I'm good to go. Next, I want to make sure that the bulkheads are clean as well. But in order to activate this microscope, I press the button here on my patch cord microscope, and now that allows me to see what's going on with the probe. There's the first one. That's a little bit dirty on that one. I'll check the other one while I'm at it. That one is clean. So that first one is dirty. Take out my IBC cleaner, remove the cap, and that allows me to go in there and clean it just by giving it a click. Now after I clean it, I always want to re-inspect to make sure that the connector is clean. And that one is. Now I've confirmed that both ends of my loop back and this port here are clean. So now I can remove my loop back from the FMAE adapter, which has been sitting here in what I call a parking lot, just keeping it safe and clean, and you're not going to lose it there. And I plug that in, and now this channel here is ready to test down on the ground. Okay, now that we've gone through all the contents of the AT&T 14 kit, let's go ahead and get it set up and ready for field use. You'll start by actually installing your software. In your kit, in the back portion of the case, will be a packet that includes a couple of things, one of which is this software disk right here. Just simply install it into your PC and follow the wizard, and you'll get your software installed in no time. After that, you'll go ahead and you will plug in your probe microscope. Now this is a digital microscope, so it comes included with a USB 2.0 connection on it. So all you need to do is take your USB connector and plug it in to an available USB port on the side of your PC. At that point, the computer will recognize it, and the first time it'll take you through a wizard where it just found the new hardware, and it'll make sure that the drivers get installed properly. Okay, next I want to make sure that I'm using the right inspection tip for this microscope as well. So what I want to do is remove the 2.5 millimeter tip and replace it with my FBPT-LC tip for inspecting LC bulkheads. I also want to do the same with my power meter. Inside this packet, as we mentioned before, is the MP60 USB power meter. Now, by default, this comes included with the universal 2.5 millimeter adapter, but I want to remove that one and replace it with the universal 1.25 millimeter adapter. Next, I want to plug this in to my PC as well. I recommend using this included extender cable that comes with it. Just plug one end into your USB port and the other end right into the other end of the extension cable. Okay, now that you have your software installed, you're ready to go in and configure FiberCheck 2 for the job site location. This is something that you'll have to do just one time at the beginning of every cell site location. Let's take a look. I first start off by clicking on the FiberCheck 2 Quick View icon here, opening that up. Now once you have the screen up, there are a few different things that you'll want to do to get things configured right. Number one, this step here, I am inspecting. You're going to want to click this drop-down menu and choose the kind of connector that you're inspecting. In this case, it's the very first one, single mode in service. The next step is answering the tip I'm using. I click on the drop-down menu there and click the first one, standard tips with BAP1. Now, before doing anything else, click down on this options button here, and you want to make sure that you configure the options menu with all the right details for saving your location and your job site information. This first tab is called Archiving Options. Now I've already created a folder here called Cell Tower, but it's really important that you name your folders for the location of the job that you're at. So here I'm going to use the example of Reedy Creek. Once that's done, I select PDF for my report format, and at the very bottom I check this box called Activate Quick Save, and I'll explain that later on. The next tab is called User Fields. Here I can input information about the company or the job that I'm working on. So I've typed in AT&T location Reedy Creek and my name in here. The next tab is called Power Meter. Here I can define where I want to save my power meter logs. I'd recommend saving it at the exact same location as your inspection archives. So go ahead and select that folder. In this case, I select Reedy Creek. And then there's a tab at the end called Options. This just has some other information about the parameters of the microscope. You can leave those as is. And then finally, when you're done, just click OK. And now you're all ready to go and to begin your test procedure. Okay, now that you have your software configured and ready to go, it's time to take a reference measurement for your optical power measurement reading. To start off, you'll be using your OLS35 light source, and you want to make sure that the port inside the LC bulkhead is clean. And to do that, you can just use your probe microscope and use your LC tip on there. Plug that in, get it in focus here, and that's clean. So now you know that that's safe and you're not going to be embedding any debris into there. Next, you're going to want to check all your test leads, the end faces for those, and the end faces for your loopback as well. So to do that, you're going to want to change your tip from the LC bulkhead tip that you used on the OLS35 and change it out to your FBPT-U12M. Go ahead and start and remove the first dust cap Inspect this one, and that one is clean. So now you know this end is clean and the bulkhead end is clean, so you can plug that one in and it's ready to go. Next, you want to check the other end of this test sleeve, and that's clean as well. Once you've confirmed it's clean, you can plug it in to this end of this little bulkhead here that came in your kit. Okay, and next we want to check and make sure that the test lead that plugs into the MP60 power meter is also clean. So plug this in, and that one has a little bit of dirt on it there. So to clean this, you just flip the cap open, give it a click or two with your cleaner, and that's a lot better. Now that you've confirmed that's clean, you can plug it in to the UPP adapter on the MP60 power meter. And finally, I want to check this test lead here. And that one has a little bit of dirt on it as well. And it's much better. So now I've plugged from my light source into this end of the bulkhead, and this cable here, this test lead, is coming out into my power meter, and I'm going to connect these with my loop back. And before I plug these in, I need to quick make sure that these are clean as well. That one's clean, and that one is a little dirty. That's better. Now I've confirmed this end is clean, and I go ahead and I can just plug this right into the bulkhead adapter. So now I have a connection going all the way from my light source into the loop back, coming out of the loop back, and into my power meter. Let's take a look at the reading here on FiberCheck 2. Okay, so I set my light source here to 1310 nanometers, and then finally turn the laser on. This indicates that the laser is on. And over here on FiberCheck 2, on my optical power meter, I also select 1310 nanometers, and you can see that there's a reading here of about minus 26.85 dB. I want to reference that. To do that, I just press this reference button here, and you see that zeroed it out now. So now that I've got it zeroed out, I'm ready to go ahead and take the optical power measurement reading from the entire channel going up and down the cell tower. Okay, now you've got your reference measurement, so you can remove your loop back, and you are ready to begin testing. What I have here is a simulation of a fiber going up the cell tower. It would connect to the loop back up at the top and then coming back down. The first thing I want to do is inspect these connections, get that into focus, and I press test on the little button that's on the side here. And what this does is this actually records the reading so that you have it on file. You can see here I've got my test result, and in the file box down in step 5 there's a blinking cursor. This shows up because I pressed quick save earlier on in my setup options. To name this, I'll call this Reedy Creek Fiber 1A, and click report, and that one's all set. I've got that one reported, so I can plug this in and I can move on to this cable here, which is the fiber simulating the one coming back down from the cell tower. Let's inspect that. That one looks good. So I'll go ahead and press the button on the probe again to get my certification report, and that shows up as a pass. So I'll plug that in here and I'll go ahead and save it. Again, the cursor is blinking in step 5 under File, and I'll call this one Reedy Creek Fiber 1B, and click report. So now you have both Fiber 1A and Fiber 1B saved and on record for your certification reports. Okay, so now I have my connection from my source going up the simulated cell tower here, and then connecting to that loop back up at the top of the cell tower, coming back and taking an optical power measurement reading. And you can see here on the screen that I have my reading here, And what I want to do is, in this open space, type in the name of this file, which we wanted to call Reedy Creek channel 1 and hit log. Okay, so now I've completed the test for the first channel, and in doing that I have 3 reports. I have the FiberCheck 2 test result for this connector here, which was Reedy Creek fiber 1A. I have the test report for this fiber here, which was Reedy Creek fiber 1B. And I have the optical power measurement report, which was Reedy Creek channel 1. So that finishes your first test. Now you can move on to your next test, and in doing so, the technician up at the top of the cell tower can remove the loopback, check the next ports that he's going to plug him into, and plug the loopback into that one, and proceed with taking the inspection reports and the power measurement reading for the next channel. Okay, so what happens when the test you just performed didn't work as planned? Well, there's a few troubleshooting tips that I'd like to give you that you can try out. The first is that you're going to want to check to make sure that all your connections are fully seated. Have the technician at the top of the tower disconnect the loopback and reconnect it again, and also make sure that all the connections here at your test lead are fully seated. The other things that you could do is use the trusty visual fault locator that's in your kit. I've got the 1.25 adapter connected to this, and what I'd recommend you do is take one end here, insert that in, turn it on, and look to make sure that you've got a blinking light on the other side. If you don't, it could be one of 2 things that's going on. You could have a bend or a break somewhere in the fiber. If that's going on, you'll see a glow somewhere along the cable. Alright, that about wraps it up. Everything that I demonstrated here is actually called out in the AT&T MOP document for fiber testing methods and procedures. Be sure to take a look. I'm Tyler Vanderploot from JDSU. Thanks for watching.